title of the paper is Mental Models and Financial Forecasts.
Great, awesome. Well, thank you so much for including a paper on the program. This is joint work with Paul Decaire and Marius Guenzel. So this project starts from a very old question, which is how do people form expectations in financial markets? And this is a question that as a field we've spent a lot of time thinking about with the benefit of increasingly more granular data. So starting from the rational expectations benchmark, this was initially challenged with mostly indirect evidence and the documentation of anomalies in financial markets. And then over the last couple of decades, we were able to make substantial steps forward with the growing availability of survey data, which allowed us to directly measure people's expectations. But even with access to these measures, the exact process through which people form beliefs still remains an open question, at least in part due to limited measurement. And so against this backdrop, this paper tries to take a step further by trying to measure not only people's quantitative forecasts, but also the reasoning underlying those forecasts, in the hope that if we're able to better measure reasoning, we'll be able to gain a better understanding of how market participants represent firms and how those representations ultimately drive biases in beliefs and contribute to return predictability. So specifically, we're interested in studying reasoning in the context of sell-side analysts valuing stocks. Now, valuing a stock is an inherently hard problem for a number of different reasons. First, it's a very high-dimensional problem. There are many different pieces of information that we may wish to attend to, but to the extent that analysts have limited attention, they have to engage in some form of dimensionality reduction and choose what information to attend to and what information instead to neglect. Oops. Another reason why this is a hard problem is that it's also computationally complex. If we were to try and apply the present value identity precisely, we'd have to forecast an infinite stream of both cash flows and discount rates. Now, this is not how most market participants go about valuing stocks. Instead, they adopt simplifying assumptions to this formula, which then translate into different types of valuation models. And so in this paper, to capture both of these aspects of analyst reasoning, we'll define a mental model as a combination of attention weights to different topics, together with a valuation method that analysts might adopt. And we're then interested in studying three sets of questions. First, how do analysts go about making these choices? How do they choose what information to attend to and what valuation method to adopt? Second, how do these choices translate to their quantitative forecasts? And in particular, we'll be interested in understanding how these choices drive changes in valuation over time and contribute to disagreement across analysts. And finally, we're ultimately interested not only in understanding how reasoning shapes beliefs, but also how these beliefs then also map into market outcomes. And so we'll try to understand how reasoning helps in our understanding of biases and beliefs, and how these then contribute to return predictability. So to answer these questions, we'll start by providing a conceptual framework with a model of both top-down and bottom-up attention when analysts are going to be deciding both what valuation method to adopt and what information to attend to based on how relevant different pieces of information are and how easy those pieces of information are to process. And in a way, this is going to be a fairly standard model of both top-down and bottom-up attention. But the challenge in testing these models in the field is that we're generally not able to observe or measure key inputs into these models. We're not generally able to measure what are market participants paying attention to, nor are we able to measure what are the models and simplifying assumptions that they adopt. And so to overcome both of these challenges, we're going to exploit the fact that when sell-side analysts provide us with their quantitative forecasts, they also write full reports in which they do provide us with information as to what models they use and what arguments they take into account to support their valuations. And so specifically using the near universe 2.1 million of equity analyst reports will prompt large language models to extract what valuation models analysts are using in practice and as well as 11.8 million lines of reasoning, each comprising of a topic that an analyst might be discussing, together with its associated valuation channel, sentiment, and time outlook. And with this new data set and guided by our conceptual framework, we'll then uncover a number of facts. The first set of facts relate about key properties of analysts' reasoning. What we find is that analysts' mental models are both sparse and rigid, and their choice of valuation method and attention weights are jointly determined not only by the characteristics of the firms that they're valuing, but also, and importantly, by their own past training and experiences. Second, we'll look at how these properties translate into quantitative forecasts, and in particular, we're going to be interested in understanding how does reasoning help us in understanding disagreement across analysts and changes in valuation over time. And what I'll show you is that while both attention and valuation methods are going to be important in understanding these differences, differences in attention play a bigger role. Another way of saying this is that differences in how analysts represent firms plays a bigger role than differences in how analysts price a given representation. Finally, in the third part of the paper, we'll look at how our measured reasoning doesn't only shape beliefs, but also translates into market outcomes. And our data set will allow us to have a pretty granular analysis of which components of analyst reasoning contribute to over and underreaction to information. And what we'll see is that analysts have a tendency to underreact more to macro-related news and to overreact more to firm-related news, especially when firm-related topics are part of reasoning about the future relative to analyst reasoning about the past. And we'll see how these patterns of over and underreaction then also contribute to return predictability. So in the rest of the talk, I'll start by providing a conceptual framework that will guide and structure our analyses. I'll then show you how we can measure key inputs of behavioral models through analyzing text data in equity analyst reports before jumping into the results. So let me just spend a single slide laying out the conceptual framework. Our starting point is extremely simple. Assume that the value of a firm depends on K features X, where these X's could be accounting metrics such as sales and costs, but they could also be intangible factors such as brand value or customer loyalty. So think of these X's as really capturing anything really that might influence the value of a firm. V's then simply capture how relevant is each variable for valuation, and therefore how much weight should each variable receive when valuing a company. From this very simple starting point, we would then want to introduce the two key components of mental models, which were attention and valuation methods. So the way that we can think about attention is to assume that analysts do not observe these X's, so they do not observe future cash flows, but rather they observe noisy signals about them. And the more attention you pay to a variable, the more precise will your perception of that information be, the more precise will your signal be. We can also introduce a valuation method in this framework by thinking of different valuation models as putting different weights on different variables. So you can think, for example, of a DCF model as putting more weight on long-term outcomes, whilst a multiple-based approach might put more weight on the company's own historical performance or on the performance of its peers. So you should think of different valuation models as approximating the true valuation function in different ways. The final ingredient of the model is going to be a budget constraint on attention, and effectively our analysts will then be choosing both a valuation method and attention weights to minimize mean squared forecast errors subject to this constraint. So far this is a fairly standard model of top-down attention where we've also introduced the choice of a valuation method. And this model will then make a series of fairly intuitive predictions, which we'll really just use to structure and guide our analyses. So first and very intuitively, these types of models predict that your choice of valuation method and your attention weights should be jointly determined to highlight variables that are more relevant, more volatile, and easier to process. Now, if all analysts had the correct beliefs about primitives and all analysts had the same processing costs, then only firm characteristics should matter in determining an analyst's mental model. If instead analysts have differences in processing costs, then analyst characteristics can start mattering as well. And specifically, if we think of processing capacity as being increasing in one's experience, the more I use a valuation method, the better I become at using it. The more I cover a given topic, the better I am at understanding how it influences valuation. So if processing capacity is increasing in my experiences, then analyst characteristics will matter, and it will lead analyst mental models to become more persistent than what would be warranted by fundamentals alone, both in the time series and in the cross-section of stocks that an analyst might be covering. Second, and very intuitively given the starting point, changes in valuation and disagreement can either be due to differences in how an analyst represents the firm, think of this as differences in attention, or to differences in how analysts weight these different components. And our empirical analyses will allow us to understand the relative importance of these two channels. And finally, if analysts have misspecified beliefs about those primitives, so if analysts misunderstand how volatile or relevant a variable is, this can lead to biases in beliefs, which then will ultimately translate into return predictability. And our empirical analysis will really allow us to have a pretty granular analysis of which topics precisely contribute to over or under reaction to information. Now, as I've already alluded to, one of the challenges in testing these types of models is that we're not able to measure key inputs into it. We don't usually measure attention, and we don't usually measure what simplifying assumption our analyst's making. And so in this paper, we're going to be exploiting a setting where we can actually start making progress on both those dimensions. So this is what an equity analyst report might look like. This was a report written by an analyst at Deutsche Bank valuing Disney in February 2017. And as you can see in the top right, the analyst is providing us with their price target. So this is their forecast of the stock price in 12 months from now. But as you can also see, there's also a full body of text, where first of all, analysts give us information on what models they're using. I know it's blurred, but in the first paragraph in this case, the analyst is providing us with information that they're using a price to earnings ratio to value Disney. And second, there's a full body of text in which they're putting forward what key arguments they took into consideration in order to support their valuation. So from these bodies of text, we'll be extracting two pieces of information. The first is what valuation methods our analysts are adopting. And second, we want to capture reasoning. Now, in order to capture reasoning, we have to start making some choices in that we need to understand how can we measure reasoning in a way that's structured and nuanced at the same time. And so to capture reasoning, the way that we went about it is to rely on some of the key components that have informed much of the debate in empirical asset pricing. So we don't only pick up a topic that the analyst might be discussing and whether that relates to the firm, industry, or macroeconomy, but we also pick up whether that topic contributes to valuation through what valuation channels. So is that topic influencing valuation through cash flows or discount rates? The time outlook, is the analyst referring to an argument that relates to cash flows in the future or the past? And finally, a measure of sentiment, which is effectively telling us, is the argument that we're measuring contributing to valuation in a positive or negative way? Now, what you see on this slide, there's a single line from the prompt that we're using to extract this information. The prompt that we actually use in the paper is pretty extensive and very detailed. We really spent a lot of time making sure that the output that we were generating was correct and also complete and stable across different LLM iterations. I really don't have time to go into the details today, but we have a lot of information on that in the paper. So this is what, instead, one of these lines of reasoning might look like. So this is actually a line of reasoning that comes from the report that I showed you earlier. The analyst speaks about how cost efficiency in US parks are coming through. And the LLM picks this up as being an argument that relates to the firm's costs. It's a statement about the present, and it has a positive sentiment associated to it. So we feed in 300,000 equity analyst reports. You might notice that this number is smaller than the 2.1 million reports that we started from and from which we extract valuation methods. The only reason for the smaller sample size is cost considerations. Running these LLMs is expensive, but you should think of this sample as being representative not only of the full sample, but also of the type of data that you might collect if you're using IBES. So from these 300,000 reports, we extract 11.8 million lines of reasoning with an average of 39 lines of reasoning per report. And these 39 lines of reasoning per report are touching on average on around 16 out of 139 possible topics. But each topic is then discussed on average 2.3 different ways. What does this mean? If an analyst is talking about inflation and is telling us how it influences valuation both through costs and sales, that would show up as two separate arguments. Now, already from these numbers, we're getting a sort of picture that analysts' mental models are nuanced in that they're talking about different topics in more than one way, but also that analysts' mental models might be sparse. They're really talking about a very selected few number of topics, 16 out of 139, in any given report. Now, one thing that you might worry at this point is to say, well, perhaps analysts are discussing 16 topics in their report, but really they're taking a much larger number of topics into account when they're creating their valuation, but they're only writing about a subset of those topics. And if that were the case, on the one hand, we would worry about the fact that we might not be capturing a complete representation of their reasoning, and on the other hand, that would caution us against interpreting this as sparsity. And so to test for this, we exploit the fact that there's only a 33% overlap in the topics discussed by any two analysts covering the same report at a given point in time. And so what we can do is we can take the topics that I'm discussing in my report, we can then take the topics that everyone else is discussing but I'm not, and we can then look at how those excluded topics contribute to explaining both my forecasts and my forecast errors. And what we find is that these excluded topics don't really help much in predicting my forecasts, but they do help in predicting my forecast errors. And so the first result seems to suggest that we are capturing a somewhat complete representations of their reasoning. And instead, the fact that excluded topics are contributing to explaining my forecast errors suggests that talking about sparsity does seem to be warranted. And so with this in mind, we can now start looking at, so what topics are analysts, in fact, paying attention to? So what this heat map is showing you is, at each point in time, what fraction of reports on average are spent talking about any given topic. Now, there's a lot of information on this heat map, and so in what follows, I'm mostly just going to be trying to highlight a few types of topics that really do suggest that analysts are paying attention to variables that are more relevant and more volatile as per the model's prediction. So first of all, we see that analysts seem to spend a lot of attention on topics that relate to fundamental drivers of cash flow generation. So you see that analysts are spending a lot of time talking about customer demand and spending, market expansion and market share, cost structure and efficiencies. These are topics that are both highly relevant and that they're changing over time. And so as per the predictions of the model, you see that analysts are spending a lot of and persistent attentions on them, as you can see from the fact that these show up in bright blue throughout our sample. Now, there are also topics that are instead relevant, but fairly stable over time. And so what we should expect is that analysts pay more attention to these topics when they deviate from steady state values. So for example, we see taxation showing up during the first Trump administration. We also see tariffs showing up in the latter part of the sample, and the same is true for inflation and CPI. The last type of topics that I want to highlight are topics whose true or perceived relevance may be changing over time. So for example, we see corporate social responsibilities and ESG showing up in the latter part of the sample. And finally, we can also see the emergence of new categories altogether. So the last topic that I've highlighted is AI and cognitive applications. And this is a category that was completely absent in the first part of the sample, but that starts showing up in the latter part of the sample. And so what this shows is how this approach allows us to discover new categories over time, and so it allows us to effectively understand changes in representations in a very interpretable way. So far I've mostly been focusing how analysts are paying attention to variables that are relevant and volatile. But one of the model's predictions is that processing costs should also matter. And so one way that we can start testing for processing costs is looking at cross-sectional differences in analysts' experiences. And one way that we can do this is by exploiting the fact that the structure of the reports provide us with information as to who your boss was when you were in training. So analysts in the report are listed by seniority. The first analyst is the lead analyst, and the analysts that follow are their subordinates. And so effectively what we can do is look at how do your boss's choices influence your own choices once you become a lead analyst yourself. And what we find is that what your analyst paid attention to when you were training under them does influence the types of topics that you pay attention to when you become a lead analyst yourself. If your boss spends 1% greater amount of attention at reporting a topic, you're going to be spending 0.59% 0.59 percentage points greater attention when you're going to become a lead analyst yourself. And this effect is stronger the longer you spend in training, and it's weaker the longer you spent as a lead analyst yourself. So what we've seen so far is that both analyst and firm characteristics seem to matter in determining what you pay attention to when you're valuing stocks. And we can also do a partial R-squared decomposition to understand the relative importance of these two channels. And in the case of attention, we see that firm fixed effects play a dominant role, but the analyst fixed effects are still meaningful as well. So far I've painted a picture where analysts approach valuation with a prior that's shaped by your training and experiences, and which they then adjust based on the stocks that they're covering. And in the paper, we show that this reliance on your experiences mean that your mental models are also going to be more persistent than what would be warranted by fundamentals alone, both in the time series and in the cross-section. And this fact that both firm characteristics and analyst characteristics matter is then something that shows up again when we turn to valuation methods. So there's heterogeneity in the types of valuation methods that analysts adopt. To see how firm characteristics matter, we can once again look at the cross-section of stocks. And for example, we see that analysts are more likely to use DCF when valuing small, young and growth firms where long-term outcomes are likely to be more relevant. And instead, they're more likely to use multiple-based approaches when valuing large, mature, and value firms. But just as with attention, your experiences come and matter once again. And to make this point even starker, one finding that to us was quite telling is by looking at geographical differences as well. So what I'm showing you here is if you take two analysts covering the same firm at the same point in time, but one analyst is located in North America and the other analyst is located in Europe, you see that they have a very different tendency of using different valuation methods. The North American analyst is much more likely to use a multiple-based approach relative to their European counterpart. And this is, again, controlling for firm year fixed effects, which once again really goes to illustrate how your training really seems to matter in determining how you go about solving problems. And so when we look at the partial R-squared decomposition for valuation methods, we in fact end up finding that analyst characteristics now actually dominate over firm characteristics as well. Now, one thing that you might wonder is, I'm showing you that there's differences in the valuation methods that analysts adopt. Does any of this matter? Ultimately, a multiple, you could think of it as a reduced form version DCF. All of these valuation methods are ultimately trying to approximate this true present value identity. Do these differences actually lead to differences in forecasts, and do they matter for market outcomes? And what we show in the paper is that, first of all, the usage of different valuation methods leads you to pay attention to very different types of topics, which already suggests that it's leading you to represent firms differently. And then the differences in valuation methods will also contribute to differences in quantitative forecasts as well, which is what I'm going to turn to next. So specifically, we're interested in understanding how differences in reasoning contribute to changes in valuation over time and to disagreement across analysts. So as per our model's framework, changes in valuation over time can either be due to changes in representations, or they can be due to changes in pricing. So think of it as changes in attention or changes in valuation weights. And so what I'm showing you in these two graphs is for each topic, how much does each topic contribute to a change in valuation, either through a change in representation, that's the left graph, or through a change in pricing. And the first thing that you can notice is that in general, the topics, the magnitudes on the left graph are larger than the magnitudes on the right graph. In other words, changes in how analysts represent a firm seem to play a more important role than changes in how analysts price a given representation. And moreover, this pattern seems to be true at the topic level as well, with two important exceptions, and that is innovation in R&D and environment. For these two topics, changes over time of how analysts have been pricing these topics contribute to changes in valuation just as much as their changes in their representations. And we get a fairly similar picture when we look at disagreement across analysts. So what we've seen is that these differences in reasoning do translate into differences in quantitative forecasts, and changes in representation seem to play a bigger role than changes in pricing. In the last couple of minutes, I want to sort of complete the circle by showing you how these differences in reasoning don't only contribute to differences in beliefs, but are also reflected into market outcomes. So the first thing that we can do is to look at which topics and which components of analyst reasoning contribute to over and under reaction to information. This is something that our data set really allows us to do at a pretty granular level. So this graph, you should interpret positive numbers as evidence of underreaction and negative numbers as evidence of overreaction. And what we find is that analysts tend to underreact more to macro-related topics, and interestingly also monetary policy and interest rates shows up. And this is a pattern that we actually see in other samples as well. For example, it's something that we see in the survey of professional forecasters, despite a different sample and a different methodology. So we thought that was quite interesting to also see that consistency. And instead, analysts tend to overreact to firm-related topics, and this is especially true when those topics are included in arguments that talk about the future relative to arguments that instead talk about the past. In the last minute, I want to show you how these biases and beliefs then also show up in contributing to return predictability. And in a nutshell, what our model would predict is that if you have a positive piece of news and you underreact to information, you should expect to have higher realized returns going forward. If instead you're overreacting to a positive news, you should expect to see lower realized returns going forward, and the argument flips for negative news. But in a nutshell, if the argument that I just put forward is correct, what you should expect from this figure is for most dots to fall in the top right and bottom left quadrant. In the top right quadrant, our measure of overreaction is positive. That's indicative of underreaction, and when people are underreacting, we see higher realized returns going forward. To the left, our measure of over and underreaction is negative. That's evidence of overreaction, and we see that that's then associated with lower realized returns going forward. So the fact that these dots are falling in the top left and bottom right quadrant are showing how these biases and beliefs do in fact also contribute to return predictability. So let me just wrap up. In this project, we were interested in measuring and understanding the reasoning behind equity analysts' quantitative forecasts and how that then influenced market outcomes. We started with a model of top-down and bottom-up attention and constructed a brand new data set that allows us to measure some key inputs of behavioral models that previously we were not able to measure. We then uncover three broad set of facts. First, when we look at analyst reasoning, we find that mental models are sparse and rigid, and that the choice of valuation method and attention weights are jointly determined not only by firm characteristics, but also by the characteristics of the analysts and their own past experiences. Second, we look at how this reasoning translates into quantitative forecasts, and we show that both attention and valuation methods matter for understanding disagreement and changes in valuation over time, but differences in how analysts represent firms plays a bigger role than differences in how analysts price a given representation. And finally, we show how this reasoning also shapes biases in beliefs and return predictability. We find that analysts underreact more to macro topics, they overreact more to firm-related topics, especially when those are part of forward-looking arguments, and this then contributes to return predictability. That's all I have, and I'm very much looking forward to Eduardo's discussion.